So starting with number 2. So we have log base 2 of the square root of x squared minus 3. Before we find the derivative of this, I want to simplify it first. I want to change that square root to be the 1/2 power. Because if I have an exponent, I could make the exponent a coefficient, and then taking the derivative is going to be a lot easier from there. So we have 1/2 times log base 2 of x squared minus 3. Now we can take the derivative. So taking the derivative of a log is almost the same thing as taking the derivative of an ln. What we're taking the log of is going to go on the bottom, so x squared minus 3 goes on the bottom. The derivative of that's going to go up top. So what's the derivative of x squared minus 3? 2x. The 1/2 is going to stay out front because that's just our coefficient. But what's the one difference when it's a log versus an ln? What do we have to do here? We need to divide by the ln of whatever our base is. So we're going to divide by the ln of 2. So that makes this question different than number 1 because it's in a log, not an ln. But we have to divide by the ln of our base. We can do a little bit more simplifying here. The 2 from the 1/2 is going to cancel out with the 2 up top. So this would be x over ln of 2 times x squared minus 3. So that would be our derivative. Perfect. Let's look at 3. So again, we want to simplify our ln here before we take the derivative. So since we have division, we can expand it with subtraction. So I have the ln of x squared minus the ln of x squared plus 1 squared. I can also make my my exponents coefficients. So 2 ln of x minus 2 ln of x squared plus 1. So now let's take the derivative. What's the derivative of 2 ln of x? Ln of x would be 1 over x, but then when we multiply it by 2, we got 2 over x. Minus, here we have 2 times, what we're taking the ln of is going to go on the bottom, so x squared plus 1. And then up top, we have the derivative of x squared plus 1, which would be 2x. We can do a little bit more simplifying. We've got 2 over x minus 4x over x squared plus 1. On the quiz, I'm fine with you leaving it like this. Another way that you could leave it, I think that you had to on the homework, would be to find a common denominator and combine it together to be one fraction. If you want to do it that way too, you can, but this is fine on the quiz. 10. Let's do 4. So same idea here. Since we're dividing, I'm going to expand it with subtraction. So the ln of x minus the ln of x squared plus 1, I'm going to change it to the 1/2 power. Then what do I do with exponents? Put the 1/2 in front of the ln. So the ln of x minus 1/2 times the ln of x squared plus 1. Now let's take our derivative. What's the derivative of the ln of x? 1 over x. Then minus 1/2 times x squared plus 1 is going to go on the bottom. What would go up top? 2x. Perfect. The derivative of x squared plus 1. We can do a little bit more simplifying here. Since I have a 2 on the top and a 2 on the bottom, they'll cancel. So we have 1 over x minus x over x squared plus 1. Again, this is fine to leave it like this on the quiz. If you want to combine it together, find a common denominator, make it one fraction, you can do that too. Next, I want to do 7. So our derivative for an exponential function We keep it the same, so 5 to the power of 2x plus 1. We have to multiply it by 2 additional things. So we multiply it by the derivative of the exponent. So what's the derivative of 2x plus 1? 2. And we also have to multiply it by what else? ln of 5, whatever our base is. So I'm just going to rewrite this. We have 2 times the ln of 5 times 5 to the power of 2x plus 1. Order doesn't really matter, but it kind of looks a little bit neater like this. Another way that we could simplify, you don't have to if you want to leave it like this on the quiz, that's fine. But another way that we could simplify is because we have a 2 as a coefficient on our ln, we could move that to the top of our 5, make it an exponent. So this is technically the ln of 25. 5 squared would be 25. So these would be the same thing. Again, you don't have to simplify it this far. You could leave it as 2 times the ln of 5. But just to show you guys another way of simplifying. Perfect. Let's do 9. So 9, we did something similar like this in the notes. It looks different than what we've been doing because we've got 2 ln's, but it's kind of the same thing. We're going to take the derivative of our ln. What we have on the inside is going to go on our denominator. So ln of x cubed would go in the denominator. And then the derivative of that would go in our numerator. What's the derivative of the ln of x cubed? So let's just call our inside ln of x cubed. Then our derivative of ln of x cubed, I'm just going to write it here for us, would be what? So if this were like a separate question. Awesome. 3x squared over x cubed. We can simplify this to what? 3 over x. Perfect. So 3 over x is going to go in our numerator. Now we can't leave our answer like this because we have a fraction and a fraction. How would we simplify? Keep, change, flip. So I'm going to keep the top, change multiplication. We're going to flip the bottom to 1 over ln of x cubed. So then we would get 3 over x times the ln of x cubed. So that would be our answer. Another way of doing the derivative, if we look back up here, our derivative of the ln of x cubed, we can take the exponent, make it a coefficient, so this would be 3 times the ln of x. Our derivative of the ln of x would be 1 over x, but then when we multiply it by 3, we get 3 over x. So it's the same thing. You end up with the same answer. You just don't have to simplify in the middle. Next, let's do 12. What would we have to do for 12? Product rule. We've got 2 terms here, x and 6 to the power of negative 2x. So we have to do our product rule. So the first times the derivative of the second plus the second times the derivative of the first. So our first would be x times the derivative of the second. So our derivative of 6 to the power of negative 2x, we keep it the same, 6 to the power of negative 2x, times the derivative of the exponent. What's our derivative of the exponent? Negative 2 times what else? Ln of 6. Perfect. Plus the second, which would be 6 to the power of negative 2x, times the derivative of the first. What's the derivative of x? 1. So we could write this a little bit neater. We've got negative 2x times the ln of 6 times 6 to the power of negative 2x plus 6 to the power of negative 2x. If you want to take out 6 to the power of negative 2x as your GCF, you can. You don't have to, but if you want to. If we did, our answer would look like this. 6 to the power of negative 2x times negative 2x times the ln of 6 plus 1. So either way would work. You don't have to take out the GCF, but if you want to. 14. 14 looks a little bit different because it's an absolute value, but we do the same exact thing. So whether it's an absolute value or parentheses, it really doesn't matter. Absolute value, we could have any number in our ln because we know that it's always going to be positive. But if it was not an absolute value, we just can't have negatives. But we're not stating the domain here anyways, so we do it the same way. I'm going to keep that 1/3 out front. So what would go in our denominator? X squared minus 1. What would go in the numerator? 2x. Perfect. So we can multiply the 1/3. We've got 2x over 3 times x squared minus 1. All right, so we're taking the derivative here. Do I use the product rule here? Why not? E to the power 3 is just a constant. There is no x's there. So when we take our derivative, that's just going to stay out front, e to the power of 3. What's the derivative of the ln of x? 1 over x. Perfect. We could write this a little bit better. This would be e to the power of 3 over x. Because 16 has an x here, we'd have to use the product rule. Do you want to do 16?
Yes, but the derivative of e to the negative x power would just be like the same thing that we did.
Yeah. We'll work it out. So here we have to use the product rule. So the first would be e to the power of negative x times the derivative of the second. What's the derivative of ln of x? 1 over x. Plus the second, so the ln of x, times the derivative of the first. So our derivative of e to the power of negative x would be e to the power of negative x times what? Negative 1. Awesome. Because we have to multiply it by the derivative of the exponent. So we could write this a little bit better. We've got e to the power of negative x, or if you wanted to put it in the denominator, you could do that too. I'll show you both ways. And then minus, I'll put e to the power of negative x times the ln of x. So if we wanted to leave our exponents as positive, this would be 1 over e to the power of x times x, or I'll write it x times e to the power of x, minus ln of x over e to the power of x. Either way would be fine. What would we have to do for 13? You could do the quotient rule. Personally, I like doing the product rule better, so I would change this to be 3 to the power of 2x times x to the power of negative 1. That way I could do the product rule. But you could do it either way. Quotient rule, you'll get the same answer. Do you want to see the quotient rule? Or do you want, okay, we'll do the product rule. So the first times the derivative of the second, the first would be 3 to the power of 2x. What's the derivative of x to the power of negative 1? Negative x to the power of negative 2. So the first times the derivative of the second plus the second, x to the power of negative 1, times the derivative of the first. So we have 3 to the power of 2x times what? Awesome. Times 2 times the ln of 3. Perfect. We could rewrite this as negative 3 to the power of 2x over x squared plus, you could leave it separate, but just to show you guys, one way to simplify it is we can move the 2 to be an exponent on the 3 there. So this would be the ln of 9 times 3 to the power of 2x over x. If you wanted to leave it just as, I mean, you could leave it like this. This is fine too as an answer. But I'm just showing you different ways. This quiz is not multiple choice, but in the future, if you did take AP Calculus, you'll have a lot of multiple choice questions. You could see it written in different ways.